Okay, so let's go. So this is vectors. Okay, we're gonna run through the whole topic first, the whole entire 3 chapters first. Let me run through everything that you need to know, and then after that we do questions. Okay, I think questions more important now. No choice. So give me about half an hour. Let me faster run through the whole thing. Okay, and yeah, we shall see. Okay, let's go. How many here don't like vectors? Okay, how many people like vectors? So all really hit it to the core. Okay, very good. So it's understandable because this is usually one of the more difficult topics. Okay, but it's easy to score, in my opinion. And also, I think the reason why vectors at schools is so tough, it's not because of the topic, it's because of the school questions. The school questions are always a bit more on the extreme side. So they go a bit more creative, a bit more messed up stuff. That's why it is more difficult. Okay, but don't need to worry. Just need to go, just think logically and everything should be fine. So let's go. We start off with the first vectors part first, which is all the algebra part and the ratio theorem. So for the magnitude of a vector, magnitude is just basically your Pythagoras theorem. Now, because you are in A levels, your vectors will all be 3 units. So your X, Y, Z coordinates. So A1, A2, A3. It's the same thing as your standard Pythagoras theorem. So this one should be straightforward, should not be a problem. Magnitude is just length. Okay. Now, what is a unit vector? A unit vector is represented by a cap. So sometimes you will see in your formulas as a cap, your length of projection, all got the n cap, a b cap, all that kind of thing. Cap just means that this is a vector with a magnitude of 1. Okay, and the following formula is just 1 over the length of a times the a vector itself. There are some examples here you can read on your own. Okay, this is how we calculate the unit vector. Pretty simple stuff, to be very honest. Okay. Okay, move on into the vector algebra part. So this is where we all know, I think you already should know by now, for the A levels or even for your own exams. Okay, you should, I'm not muted. I think you are muted. So you need to know that for your questions, it's always one on your scalar dot product questions, those that require a bit of the algebra side. The other one is your messed up kind of big application kind of question. Okay, so how to practice for vectors, do these 2 types of questions. It will come out and guaranteed for your exams. Okay. The one that, if you ask me, is the easiest to score is the first part, the algebra part, because that's not very difficult. It's only the questions where you have like what, one plane find this way, then got one laser shoot up, then touch the plane, don't know what shit. All this kind of very, very weird kind of question, then I understand it's difficult. But in general, shouldn't be that bad. Okay. So when we're doing addition, okay, we have the commutative laws and the associativity laws. Hello. Yeah, you again. Hello. If this comes to too big, then we move like that. Moving on. So we have the commutative laws and the associativity laws. The names of the laws we don't need to know, but you need to know how does it work. So for example, A plus B is the same thing as B plus A. Okay, like for example, your dot product, cross product is all the same. A dot B is the same thing as B dot A. A cross B is not, it's negative of B cross A. Later we explain why. Okay, it's really simple. Multiplication is just distributive and associativity. You can distribute it out and you can change the way the brackets are being moved. If you ask me this whole entire page, what is the most important one? Will be the last 2 under your parallel vectors and your equal vectors. Now, let me explain to you the concepts first. Why? So that you can easily understand why is it so important. Now, vectors are known to be unique. And when we say something in mathematics is unique, it means that there's a very unique way of representing something. Okay, I'll give you something that's a bit out of context. For example, your chemistry. Okay, just do something like that. Okay, from what I understand about chem, okay, every compound should have a very specific way of writing their chemical compound. It's the same thing here. All vectors are very unique. There's only one way in writing a vector. So that's why whenever we put an equal sign in between 2 vectors, it means that the components are the same. It means like, for example, the X components are the same, the Y components are the same, the Z components are the same. You get what I'm trying to say? Okay, that is what it basically means by equal vectors. For parallel vectors, this is something from your O's. Parallel vectors is basically when there's a lambda, it's just a constant. Okay, when it is multiplied by a certain scalar constant, then you know that the vectors are going to be parallel. Okay, two things that you need to know. There's no such thing as divisions of vectors. That one really cannot. Okay, so this one don't need to worry about it. Next, scalar multiplication. For scalar multiplication, you need to understand what is the effect of the scalar multiplication. If it's greater than 0, means you're still moving in the same direction, but you're making the vector either longer or shorter. Longer if the lambda value is greater than 1. Shorter if it's like 0.5. Obviously, you'll be shrinking the vector. That's it. When you times lambda to be a negative value, means that we are moving in the opposite direction because your minus sign changes the direction of your vector. Understood? Same thing for the numbers. If it's -2, means you're making it longer, but you're changing the direction. -half, opposite direction, but half the line. Understood? Simple enough to understand? Okay. Now, this is important, geometrical interpretation. Now, many people are very bad in the way that they do geometrical interpretation questions. So please, let's look at this. A plus B and A minus B are known as the diagonals of a parallelogram. If you didn't know this, then look at this. This is how to explain why. For example, if this is vector A and if this is vector B, what is your diagonal? It's just like that. That's why A plus B is just the diagonal of your vector. The other direction, this way maybe, is your A minus B or B minus A. So for example, if you see questions, can you tell me what is the geometrical interpretation of your vector? Sometimes if you see things like this, we'll be talking about that, okay, about parallelograms. Maybe on certain cases, they will ask you like, oh, okay, is it scalar, is it parallel, or whatever. Understood? Okay, now moving on, proving quadrilaterals. So this one is a little bit more rare, but I usually like to say this kind of thing. If you come from a more messed up school, okay, questions, they like to test this kind of questions where they ask you to prove that something is a certain shape. The most famous shapes out there will be your parallelogram and your rhombus. Okay, so if they ask you to prove, you need to prove any one of these statements. It's not all, any one of these statements. Understood? Okay, this one I'll let you read on your own. Okay, it should be pretty straightforward. Now, there's one that maybe I just want to point out. You notice the words and. It's not an option. It means that you need to prove both the fact that AB is parallel to DC and AD is parallel to BC. Okay, simple enough. But these are rare, so don't really need to worry about it unless your school likes to test things a little bit out of the way. Okay. Beautiful. Now we go into 3D vectors. Now for 3D vectors is basically just an additional direction. So your IJK components, you have an extra Z direction. Now let's look at that grip thingy that I drew there for you. What is that? How do you actually tell where is your IJK position? Based on the way you do your right hand rule. Okay, I believe in physics, if you have learned before your right hand grip rule or something like that, I don't know in what topic, I forgot. Electromagnetic induction? Whatever, cannot remember already. Okay, but okay, so you have your grip rule, you can actually see how your IJK positions will be held. So for example, if I look at it like that, right, you see for those basically here, what I like to say is this: if this is I, your J will be curled inwards, your K will be this way. Understand? That's how I tell that. Okay, so I, J, when you squeeze in, K pointing up. And you must be right hand, cannot be left. Okay? Nice. Useful results. So all this here, I believe these are things you already know, your units, your scalar multiplication, your equal vectors, your subtraction, addition, and your distance, all the same, just add an extra direction. Okay? Now, vectors, is it actually really tough? If you go further, right, like what I study, right, it's no longer 3D, it's like n dimension. Okay, so for now, this is just 3D, it's pretty cool, still can imagine, but you reach my realm, cannot already, because you cannot see. Okay, now collinearity. When two vectors are collinear, it's basically saying that they are scalar multiples apart. The only difference is just that there is a common point. So what's the difference between parallel and collinearity? It's about the same thing, The only difference is just that there is a common point. Okay. So in questions, you need to be super careful. B is the common point here. That's why these two vectors are collinear. Okay. If there's no existence of a common point, then of course it is just parallel. Now question, is it necessary for the common point to be in the center? No, obviously not. Okay, it can be anywhere else as long as there is a common point, you know that it's definitely collinear. Understood? Any questions? Okay, the proof you read on your own, the example you read on your own. I'm trying to chung to the question. Okay, so yeah. Ratio theorem. Okay, for the ratio theorem, a lot of people have some problems at this stage of identifying what kind of questions need ratio theorem. Okay, to be very honest, if you go and think about it, most of the time, your algebra topic, the algebra part of the question will definitely require you to use your ratio theorem. Things that you can look out for, fractions, whenever they give you ratios. These are things that definitely you need to use your ratio theorem. Now, the ratio theorem states that you can find what is the vector of the line in the middle. Okay, that will be your OP vector. Okay, and the formula is given there. This formula is found in your MF26, so you don't need to memorize, but good to remember the whole thing. One thing I will say that is very important about the ratio theorem is whenever you face things talking about midpoints. So for example, sometimes questions will say, there's a certain point that is a midpoint between your line. Straight away, instead of using the whole entire ratio theorem formula, you can just times half. Why? Because the ratio is 1:1. Understood? Another example that I didn't put here that is very popular whenever you do ratio theorem questions. Does anyone know? Starts with R. Very good. Reflections. Whenever you face reflections of a line with a point and a point, is always ratio theorem. Okay, so reflections. This is another case where you need to look out for it. Okay. Now, there are two types of reflections. You can either reflect a point or you reflect a line. So let's say, for example, if you're reflecting a point, how do you reflect? Basically, okay, you just imagine if there's a point here, this is your line. From here to the foot of perpendicular is the same distance from this foot of perpendicular to the new reflection point. How about a line? How do you reflect a line? What are the two things that change? Your direction vector and also your point. The point can be found with the exact same method, but how do you find your direction vector? Okay, let's think about it. If you reflect, just by logic, you do a reflection about a center line. There is something that is common between these two lines and this mirror. What is that? The what? Very good. The angle. The angle between your mirror to the vector is the same. So that is something that you can use to also search out for your direction vector. Understand? Okay, nice. Next one. Whenever you're given unknowns, now please do not use lambda and mu within the same equation. Whenever you face things with unknowns, you should always do lambda and 1 minus lambda. Because the more unknowns you introduce in, the more you're going down a very dark hole. Okay, there's no way you can solve questions with so many unknowns. Clear? It's just strategy in exams. Nice. Any questions before we move on into the next part of the topic? There's something wrong with the audio. Wait. Hello. Can Wait. Okay, thank you. Can hear. Okay, I think for those that cannot hear, it's most likely your side, not me, because there are people that can hear. Okay. And I'm talking as loud as I can already. Correct? It's loud enough, right? Okay, very good. Next, dot and cross product. Now, dot, yeah, sorry. B is produced. Oh, okay. So for those kind, basically it means that, okay, the reason I never put in is because it's rare. But when you say B is produced on AB, it means that, for example, if your AB is like that, produce means that it's either you extend out that way or you extend backwards. Yeah, that's basically it. They share the same direction vector. The only difference is just that most likely is your ratio. Like for example, if this is 1, this is 2, then 1 is to 2, that kind of thing. Yeah, that's what it means by the production kind of questions. Okay, but thank you for the question. Next, moving on. Dot and cross product. Now, the way that I teach dot and cross product is slightly different from schools. What I will do first is to explain the algebraic way of doing the questions. Then we talk about the geometry side. Okay, because there are two halves. there's always the algebra and then the geometry. This part a bit cold, so just be careful because the aircon is just right behind. I'm just letting you know. Okay, so we start with the algebra part. Now, I believe everyone knows dot product is just take the numbers and multiply. So for example, A1 times B1 plus A2 times B2 plus A3 times B3. That is your dot product. So far, okay? Let's talk about the laws of your scalar dot product that you need to know. A few that are very important. The very first one, A dot B is B dot A. This one you should know. A dot B is always equal to B dot A. Okay, this one nothing will change. Distributive law, not very important, but just know that when you do A dot of two vectors with a sum, it's just like your algebraic expansion. So A dot B plus A dot C, not A times B plus A times C. No, in vectors, there's no times, it's always dot or cross. So just be careful. This one is also super important. The product law for scalar product. A dot A is mod A squared. You need to remember the mod. And this is why some questions, the mod will suddenly appear out of nowhere. Okay, it's because of your dot product. The mods are very important. One more thing I want to see. Okay, if you look at the last line, there is this word here, IFF. Okay, this is not a typo. I say first, this is not a typo. This is a legit mathematical thing. Let me explain what this is. This means if and only if. Have your school explained this before? What is if and only if? Okay, if and only if means that it works both directions. So let me explain. When you say something, if something, it means it's one way. If you say something, IFF, something, it means it works both ways. It means what? A dot B equals to mod A mod B if A and B are parallel to each other. Also, A and B are parallel to each other if A dot B equals to A mod B. Understand? The sentence works both ways, not just one. Clear? That's why there's an IFF. If you see some of my way I write, right? Sometimes I say only if, it means it only works in one way. It doesn't work the other direction. Clear? Okay, good. Okay, let's talk about a few things here that are pretty important. I think if I remember correctly, second and third bulletin point pretty important. A dot B with a C on the outside, I hope you can see that this becomes a vector. Why? Because A dot B is a numerical value. This is a scalar. And then your C becomes a vector. Understand? So that is a vector. If A dot B, A equals to 0 or B equals to 0, then A dot B equals to 0. Okay, so maybe I can use this as an example to explain the IFF thing. If you realize the way I wrote this bulletin point, if A equals to 0 or B equals to 0, then A dot B equals to 0. But does it mean that A dot B equals to 0 implies A equals to 0 or B equals to 0? No, it doesn't. It only works one way. Okay, so just be careful. Any questions? This last one is also pretty important. Do you know why is it undefined? Why is it that A dot B dot C is undefined? Because? Why? Why is there no such value for A dot B dot C? Very good. Then after that? It's not you cannot dot again. You cannot take a scalar dot a vector. It doesn't make sense. It's a vector dot a vector become a scalar. It cannot be a value dot a vector. Doesn't make sense. Understand? That's why this is undefined. Now, the geometric definition. What does it mean by dot product? Now, the dot product is the following formula here. A dot B equals to mod A mod B cosine theta. This is something you need to memorize. One thing also as well, theta is a non-reflex angle. Non-reflex means either acute or obtuse. How do you tell whether is it acute or obtuse? Look at the top. If your A dot B is greater than 0, I think it's written somewhere, but if it's not, then if your A dot B is greater than 0, means this is acute. If your A dot B is less than 0, this is obtuse. Okay. If it's not written inside, you can jot that down. Now, next thing that is also very important when you're talking about the angles between two vectors. Now, angles, please remember very carefully, is either convergent or divergent. What does this mean? It's either you go away from a point or you go into a point. It is not one in, one out, or you're finding the reflex. No, it's always go out or you come in. Clear? So the why people get mistakes in this thing is because their direction got a problem. You need to be careful of the way it is being pointed. Then you calculate your angle. Understand? Okay, very good. Any questions before we move on? No, okay, very good. I think it's written here. Very nice. So A dot B acute greater than 0. A dot B obtuse means it's less than 0. Okay. Now for perpendicular vectors, two non-zero vectors A and B are perpendicular if and only if. Okay, see the way I write this, if and only if A dot B equals to 0. What does this mean? It means two things. Number one, if I tell you that A and B are perpendicular to each other, it means that A dot B equals to 0. It also tells you that if I tell you that A dot B equals to 0, it means that A and B are perpendicular to each other. Understand? Understand what does this sentence mean? Be very, very clear about it. It works both ways. Okay. Any questions? No. Now let's move on. Cross product. For the cross product, okay, this is the formula here. Now, I don't know how your schools teach it to you, but one way I like to do it is this. Okay, just to very quickly show how I do cross product. When you go from row to row, let's say, for example, you want to find the top component. I just cover this with my finger. Or I mean, in my head cover, not like that, look very weird. But in your head, you cover the first two, then you do a multiplication. Okay? The second row, you cover the middle two, and then, you put a minus sign on the outside, and then you do A1, B3 minus A3, B1. For the last row, same thing. You cover the last row, and then you cross. Then you'll give you the answer. That's how I do it. So that you just remember it's always like that, then like that. Okay? Then just remember the middle put a minus sign. Then can really. Simple enough. Some schools, I believe, they will teach you to, the very strange way is to teach you, if you're doing the second row, you move this whole thing down, and you write your A1, B1 here, then you do your cross. I don't know, I'm pretty sure some schools teach it this way, but it's damn confusing. So just follow this way. Just cover, and write. Okay? Any questions? Next, cross product. Okay, the one that is pretty important, I would say, is this. Okay, the rest you can read on your own. The product law for scalar product. When you take A cross A, is equals to 0. Why? Can someone give me a reason why when you take A cross A, you will get 0? What's the reason? Very good. Nice. Okay, good job. So let me repeat. When you take A cross A, what does it mean? You're looking for the angle between the two vectors. Now, A and A will be parallel to each other. Are there any angle in between the two vectors? No. That's why it's 0. Understand? Very good. Good job. Thank you. Okay, moving on. Okay, nice. A cross B is not the same thing as B cross A. Why? Very simple reason. We use the grip rule again to remember. When you take A cross B, okay, remember just now how I do my I and J thing, IJK thing, right? So if my I is this way, my J is this way, means my K is this way. Still. Okay, so like that, right? This is A cross B. But now, if I do B cross A, it's like that. My B is this way, my A is this way. Notice the way that my thumb is being pointed. It's in the opposite direction. That's why there's a minus sign. Understand? Minus sign means you're facing in the other direction. Clear? So A cross B is just negative of B cross A. There's an exception to this. If they write mod of A cross B, is this statement true? Obviously true. Okay, why? Because of number one, the mod, and number two, you're finding the length of the normal vector is the same. Okay, nice. Another thing, A cross B will always give you a vector. Now, please remember that all these zeros here are vectors, not numerical values. So when you're doing the cross, your 0 must do the thingy underneath. Okay. And look at the way this sentence is written. If A equals to 0 and B equals to 0, then A cross B equals to 0. Does it mean the other way is true? No, it doesn't imply that. Understood? Let's talk about the geometrical definition of the vector product. This is the formula here. A cross B equals to mod A mod B sine theta n cap. You're from CJ, right? You're from CJ, right? If I'm not wrong, right, I saw your this year's notes. There's I don't know whether your school got say, there's a typo in this page, like one of the parts here. They never put the n cap, or they never teach you the n cap thing. Is it true? Have you seen this before? At the back of the formula? Yes. God. Okay, then I might be wrong. But I'm pretty sure I didn't see it that time. Okay, I'll go see again. Okay, so anyways, this is the formula for the geometric definition of a cross product. It's with a sine theta. Okay, now there's a way to see the way that we see the way we do the cross product. It's same thing using your this grip rule thingy from physics lah. Your Fleming right hand rule like that. Okay, so A cross B normal vector. Okay, this is just your physics concept. If you take physics. Okay. Any questions? You okay? Okay. Behind all okay? Okay. Behind okay? Nice. Okay, perpendicular and parallel vectors. Now, when two vectors are parallel, okay, A cross B will be equals to 0. Why? I mean, the reason already given just now, A cross A is also 0 because they are facing the same direction. For this, why is A cross B equals to mod A mod B? Just memorize. Okay, there's a way to prove it, but for now, you can just memorize it. Okay? I don't get why got n hat. Okay, wait. Okay, this one I don't need to flip. This one I can explain very fast. This thing here, you don't need to know why. Don't bother. Yeah, don't bother. Don't bother. Huh? Yeah, correct. It's just n cap equals to 1. That's why when you take the mod of A cross B, that thing vanishes. It's just that without it, then you got the n cap. But a lot of people will just kind of ignore it, to be very honest. Okay, so yeah. This one is a bit difficult to explain. So this one, there are certain things in this chapter that is a bit hard to explain. Like people will usually ask, what is a zero vector? How to answer? I mean, I can answer that, but it's going to be very cheap. But what is a zero vector? It's a vector with no direction, no magnitude. Then people will ask, is it a point? No. Is it a plane? No. Is it a line? No. What is it? It's a space. Can you understand what is that? Yeah, so don't bother. Understand? Okay, so for now, just don't bother. Okay. There are certain things that I just don't want to explain. It's way too difficult to understand. Okay, next, A cross B. Okay, so A cross B, this is the diagram here that you can use to imagine. Now remember, A cross B will always be used to find your normal for your plane. Okay, just remember that this gives you the perpendicular vector to your plane. Another thing, it is always positive. A cross B should always be a positive value. Okay, the magnitude of that should always 100% be positive. Last thing, okay, all these formulas here are very true. Okay, I dot I, J dot J, K dot K is always equals to 1. Okay, but I dot J, J dot K, K dot I is equals to 0. I cross I, J cross J, K cross K is also equals to 0. Now, sometimes questions will ask you, what is the YZ plane? YZ plane is just this long. In case you don't know, just letting you know. What is the XZ plane? It's just this thing in purple. And what is the XY plane, the one on the floor? So sometimes when questions say like that, then one of your components will be 0. You get what I'm trying to say? For example, okay, if you cannot imagine, let's say if I have a point on the XY plane, that means my coordinate here will be, for example, A, comma B, comma 0, because there's no Z. Simple. Okay, so if you see these kind of questions talking about the planes. Okay, applications. So your triangles and your parallelogram. Now, this is where people will mess up sometimes. So be careful. Remember, I talked about the angle, the direction of the way your vectors are labeled, the way your vectors are drawn. Be careful. Convergence or divergence. Okay? Is intentional. A, B, A, C. Cannot anyhow flip the letters anyhow. Okay? My favorite concept. Length of projection and projection vector. Okay, if you're horrendous at this and your school didn't explain it to you well enough, just remember this. Length of projection is the shadow. projection vector, okay, or length of projection is the shadow on the floor. And then the other one is going to be your wall. One is to be the shadow, one will be the wall. How I imagine is this, just follow up. You take a light source and you shine the light on your vector A. Two things will happen. You're going to get a vector, or you're going to get a shadow on this floor, right? Once you cast that shadow. This is what we call the length of projection, okay, or the projection vector. The length of that projection will be that long. Okay, so far clear? Now, this other one, the perpendicular one, this will be the wall. This is the wall. What I would do personally is just to memorize one of them. You don't need to memorize all four. What's the reason why? Okay, just watch. Just memorize this. A dot B cap, B cap. Wait, yeah, A dot B cap, B cap, correct. Okay, but you need to remember, how do you find this vector here? Just travel from here to here. Is this long? So it's just A minus A dot B cap, B cap. Okay, so this is how you calculate your length of projections. Any questions? And of course, how do you find the values? You're just, for this, you find the cross, and for this, you find the dot, and just memorize. Okay? Any questions? This is just memory work, to be very honest. Okay, moving on. Lines and planes. Okay, for the lines and planes section, okay, we're going to talk about lines and we're going to talk about planes. Okay, foot of perpendicular, right? You know what? Coming. Okay, so we'll talk about lines and planes. Okay, if you realize here, there are certain things that I didn't go through, which is like the points and something, right? Okay, there's a reason why. You don't need to flip, I flip for you. Wait, you look at this set of notes, the way I designed it is this. I give you the whole entire chapter 3. I give you lines, then I give you planes, then I give you every single possible combination. A point to a line, 2 lines, a point to a plane, line and a plane, 2 planes. Understand? All the 5 different possible combination of questions out there. Just memorize every single one or understand every single one. There is one more very unique one, depends on what kind of school you come from, 3 planes. So imagine you take, okay, sorry. Okay, 1 plane like that, 1 plane like that, and then 1 plane like that. Or like that. That kind of very, very funky thing. Okay, if you ever encounter, all the best. Okay. So let's go through what a line is first. Now, we start off with the vector equation of a line. R equals to A plus lambda M. Now, if your school didn't explain to you what is the definitions of everything, listen carefully up. R is a general point. General point means anywhere along the line. Just a random point somewhere on this line. A is a fixed point on the line. M is your direction vector. Okay? So that's your equation of a straight line. Or a vector equation of a line, of course. Inside this whole entire paragraph here, you read on your own. One thing that is important is this too. I'll briefly run through what this means. Lines are not unique. Okay? Lines are not unique. What does this mean? It means that every single line that you can write, they can come out with different values. Like you just need to change your point, the value changes a little bit. Understand? So it's non-unique. You don't need to worry about that. If your answer come out in exam different from your friends, there's nothing wrong with it. Okay, unless it's severely wrong, then of course it's your fault. Okay. The last one, what happens when the line passes through the origin? These are things that you need to spot yourself. Because of the way vector questions are designed, they will purposely make information very sparse to you. So you need to see specific things. When you see that there's no point there, it means it definitely passes through the origin point. Okay? Okay, the rest, read yourself. Okay. Parametric equation. So for the parametric equation, the way I memorized it is this. Change your R into XYZ, and then you write your equations. 1, 2, 3. These are your 3 equations. Understood? For your Cartesian equation, make every single row lambda the subject of the equation and equate every single one. That's how you convert. Clear? Simple. Any questions? This one is basics. You should already know what is an equation of a line. Moving on, equation of a plane. We talk about a few different forms. Equation of a plane got 3. Yeah, 3. Which is your scalar product form of a plane. R dot n equals to D. Okay, let's clear one common misconception. The D value. Is the D the distance? between, okay, what funky thing I've heard so far over the few weeks? People say that D is the distance between the origin to the plane. Is that true? No. D is just a constant. It's just a random constant value. Okay, you do not confuse this as the distance between the plane. It's not correct. Be careful about that. Same thing is just a general point. N is your normal vector. So you need to find what is the normal vector in order for you to write down the equation of a plane. One thing that is important here, okay. If A dot N equals to 0, it means that your plane passes through the origin. Okay. And this is important, this bulletin point here. These are the 4 examples of different cases where you can search for the equation of a plane. What can they give you to find the equation of a plane? Some of the more popular ones, they give you 2 lines on a plane, find the equation. Understand? So for example, let's just very quickly run through. If I give you 2 lines on the plane, how do you find the equation of the plane? You take the direction vectors of these 2 lines, cross, find the normal, equation done. Understand? That's one way you can do it. For example, if you have 3 points on a plane, how to find the equation? Take the 3 points, find 2 direction vectors, cross the direction vector, find the equation. Simple enough. If I tell you one vector is floating above and is parallel to the plane, and you have a point, how do you find? Direction vector, okay, there's one. You have another direction vector on the plane, cross, you have the point. Solve. Understand? It's just different combinations of ways you can find the equation. Okay? Any questions? Yeah. Parametric form. Now for the parametric form, this is how it looks like. A plus lambda B plus mu C. Please remember that lambda B and mu the C, B and C, these are direction vectors. Okay. Now the direction vectors, do they need to lie on the plane? No, it's not necessary. They can just be floating above, parallel to the plane. Okay. Cartesian form. Basically, what you're going to do is just to rewrite your R and your N in terms of N1, N2, N3, and X, Y, Z, and then you can write your equation. Just remember, D is just a random constant. Now, let's go through all the different calculations and the different ways and the different types of questions that can come up. So how I would recommend studying this, okay, this set of tick notes here is exactly the same as the tiny booklet. Every single combination is all written for you there. You just need to remember what type corresponds to what method. Okay. Let's start with a point and a line. What kind of questions can come up? How do you tell whether a point lies on a line? Okay, we go back into secondary school. Last time in your secondary school, if you want to tell, like, for example, one coordinate lies on the line, what do? Sub the point into the line. It's the same logic here. Sub the point into the line and verify that all the components are exactly the same. That's all. As simple as that. Okay. Find the foot of perpendicular from a point to a line. How? There are 2 different ways here. The one I recommend will be the first one. Okay, this is the most common method that people will do, okay, which is this. The foot of perpendicular lies on the line. So you can rewrite this foot of perpendicular into the vector form. Now, we know and we can write what is this in terms of a vector as well. So once you have written this in a vector, write PF in a vector, and because we know that the perpendicular, the dot product is 0. Understand the logic? Since the dot product is 0, solve for the value of lambda, sub the lambda value back into OF, get the vector. Very straightforward. Okay. The other one is the length of projection. This is another alternative method. This one leave it to you to read on your own. I preach the first method. It's a little bit longer, but more logical. Okay. Moving on. Finding the perpendicular distance between a point and a line. Now, it's exactly the same method as the previous question. The only difference is what? Do you remember that we have already calculated PF vector, which is this? This is the length long. You just mod the PF and you get the answer. Understand? So you repeat the same process. Find the F, find the P, yada, yada, yada. Once you have found F, you find the mod of the PF vector. You get the height very, very easily. Understand? Okay, there are 3 different ways. Of course, all the methods you can read yourself. I preach the foot of a particular one. Moving on, finding the position vector of a reflection. Okay, this is the concept on reflections. Reflections about a point or about a line. So remember, the distance between the point to the foot of perpendicular is the same distance from the foot of perpendicular to the new reflection point. Okay, and the formula that people memorize is just this. This is the ratio theorem version of the formula. It's the same thing. Okay. Any questions? Just okay, like how I will study, just remember the different types of question. For the perpendicular, do this. Reflections, do this. Then just continue and just do it like that, or just partition your head like that. Okay. Moving on. Is this too fast? Is this okay? Okay. Calculations involving two lines. Now, you need to understand the relationship between two lines. This is a beautiful diagram drawn by a certain school. Okay, that I love it a lot. Okay, that's why I decided to copy it from their school because it's pretty good. Okay, so this is a branch, basically a whole entire train process that you can work out. And how do you work out what is the relationship between two lines? So step one, to check, we need to check first whether L1 and L2 are parallel to each other. How? Look at the direction vector. If the direction vectors are the same, then we know that they're parallel to each other. Okay, or they're scalar multiples, of course. Then we know automatically they're going to be parallel. Now remember there are three: parallel, intersecting, skew. Okay, so we clear the parallel one done. Now, if it's not parallel, then you move on into step two, which is to do simultaneous. Simultaneous the two equations to search out for the value of lambda and mu. Two methods of how is written here. Okay, basically is this. If you can find a consistent value of lambda and mu, these are intersecting lines. Means that there exists a point between these two lines on the two, basically like that. There's a point here. That's why there's a lambda and mu. If there's no lambda and mu value, means it's skew. If it's not parallel, it's not intersecting. Understand? That's why this tree, I believe, is pretty good to understand the whole entire chain. Okay. Next, finding the position vector of the point of intersection between two lines. Basically, the idea is just this part. How do you find the intersection between two lines? It's just this portion of the process. Okay. Angle between two lines. Okay, for this one, angle between two lines. The formula is this: theta is equals to cosine inverse of m1 dot m2 over m1 m2. Now, what is m1 m2? m1 m2 is your direction vector of your lines. You need to be very careful about something. Okay, you need to look at the way your m1 and m2 are pointing. Now, if it's pointing away from each other, then the angle will be acute. Okay, if it's obtuse, then you need to remember to do pi minus theta. Okay, just be careful of the way that it is being drawn. Then you can get your angle. Any questions for this? Calculations involving a point and a plane. So I believe here got a few different types. Determining whether a point lies on a plane. Same thing as a line. To determine whether a point lies on a plane, sub the point into the plane, verify that every row gives the same d value. Make sure the dot product gives the d value. You get what I'm trying to say? Okay, one question that someone asked the other time. For example, if I give you r dot, maybe 1, 2, 3 equals to 10. And then the question asks you, can you find for me a point that lies on this plane? How? Inspect. Yeah, you need to make a point. So the question is how to make a point. How? Oh, can. Very good. 10, 0, 0. So basically, you just need to come up with three numbers here. When you do the dot product, it gives 10. You get what I'm trying to say? So it can be a lot of things. It can be 10, 0, 0, 0, 5, 0, 1, 0, 3. So many possibilities. Okay, that's how you find a point on the plane. Okay, if you need to magically pull out a point on the plane, this is how you do it. Use your eyeball and see. Okay. Put a perpendicular from a point to the plane. Exactly the same concept as the line to a plane. Just find the distance PF or find the vector PF. You can get it. It's very, very straightforward. Okay, and another thing you also can remember It's just that this point is above the plane, right? This is parallel to your normal vector. Okay, because your normal vector is this way, your PF will also be this way. These two lines are going to be parallel. Okay, that's another way you can look at it. Very, very simple. Moving on. Perpendicular distance between a point and a plane. This is just for a perpendicular law. You're just looking for this particular distance, aka is just the same as the previous method, just finding the distance. Okay. Line and a plane. Now, for a line and a plane, you need to know the relationships between a line and a plane. Three different cases. Line lies on the plane, line parallel to the plane but not on the plane, and the last one is intersecting the plane. So what are the three different ways? For if it lies on the plane, it means what? The direction vectors are the same. And another thing, a point on the line also lies on the plane. Understand? If it's parallel to the plane but not on the plane, basically parallel to the plane, but the point doesn't lie on the plane. Okay? Last one, intersection point between a line and a plane. Your direction vectors are not parallel, and what you do, simultaneous. Sort the two equations together, find the value. Okay, all the steps are all here for you. And I believe you're almost done. Wait, how far more? Okay, almost done. Last one, angle between a line and a plane. How do you find the angle? So basically, we're going to use your cosine formula again, but you need to be a little bit careful about what you're finding. Cosine theta will give you this. Okay, the reason is because you're converging towards a point. That is the psi value that you're finding. You need to take 90 minus theta. This is the angle between the line and the plane. You need to be very careful. It's always 90 minus theta for this case. Understand? It is not this angle that you're finding using cosine theta. You're finding this. And this is the reason why people actually use the sine version instead. Because why? Sine will just straight away give you this angle. You understand the logic? Right? Okay, sine will straight away give you the theta value. But if you're using the cosine version, they will give you the one on top. Then you take 90 minus that to get the answer. Okay, if you need the reason why, very simple. The reason is because cosine theta is equals to sine of 90 minus theta. That is the reason why. Okay? Can you understand what I'm trying to say, right? Moving on, calculations involving two planes. So you need to know the relationship between two planes, whether they are parallel or whether will they intersect. So two different cases, if they're parallel, means their normal vectors are parallel, obviously. Okay? If they are non-parallel, means their normal vectors are not parallel. As simple as that. The distance between two planes, this is the formula. Okay, this one is a little bit rare. Some schools didn't teach this, so just be careful. The distance between two parallel planes will be AB vector, sorry. A point on A, the point on B, you find the direction vector, dot, and cap. Okay, it's just a formula. This is important. And I believe the last two pages, the line of intersection between two non-parallel planes, the whole entire method is given to you. Okay, two different ways. What we do is we use the equations, we rewrite the equations into the Cartesian form, solve for the equation. And you make sure that there is a consistent value among all three. That's method one. Method two, use the fact that there's going to be a common point that is both common to both planes, find the cross product and get your answer. Okay, the line of intersection is perpendicular to both the normal vectors of A and B, and it's also parallel to A cross B. Okay, this is how you find the equation of the line. And the very last thing, before we can look at some questions together, angle between two planes is the same thing, long. It's just your same formula with your line, okay, your cosine theta formula. If it's acute, then it will just be this. Just be careful of the way your direction vectors are. Okay, for the other one, it's just going to be pi minus the angle. And we are done. That's the whole entire topic. And every single possibility of questions that can come up. Okay, now it's your time to try. Okay, let's do 1 to 2 different questions. Okay, I do want to look at the big application question. So if you actually see through, there's quite a bit of messed up stuff at the back. Okay, so yeah, let's look at something interesting first. Okay, let's do something easy first, easy to warm up first. Let's look at question 2. This one. This is the ACJC question. Okay, I'll give you 10 minutes. Try. No, correct. Okay, so if you want to check your answer for the first part, answer is A plus KB over K plus 1. Here's the first part answer. Okay, do you need help? Let me go through the second part. Okay, because all the physical people got it for the first part. So no, you just continue, I'm talking to the people online. Okay, so I'm gonna go through the first part first. Okay, in case you cannot get the two of you behind, you want to listen, can listen all. Okay, so if you want to listen again, how to get the answer for part A, okay, listen carefully. So we are given a situation. Wait, let me pull the question. Okay, so well, given that the mod of A is 2 and B is a unit vector, the angle between A and B is 60. Point C lies on AB. So this is very important. So we have a line here. This is A, this is B, this is obviously C. Okay. And we have an origin point, obviously. So let's mark out an origin point. So this is O. So what do we know? We know that AC is K times of CB. So this one must be a bit careful. AC is K times of CB. So some people will label the length wrongly. AC over CB equals to K over 1, which means that this is K and this is 1. Okay. So if this is vector A, this is vector B, by ratio theorem, you have A OC vector equals to K plus KB over K plus 1. And that's the answer. Alright. Okay, so this is the answer for part A, yeah? Using ratio theorem. Okay, understand? Okay, if you need the corrections, this is how you do it. Okay, now the next one. We're looking for the length of projection. So length of projection. Okay, so just watch how I do it. Length of projection of OC onto OA. So what's the formula? Okay, I'll just scroll back first to see the formula. Length of projection. Somewhere here. There we go. Okay, length of projection onto the vector, so it'll be A dot B cap. Okay, that's the formula. A dot B cap. Now, if you forgot how to break down the B cap portion, so just watch how I do it. Okay, so be careful of the way that it must be written. So we have this answer here with the mod of OC dot B cap. Agree, right? AC dot B cap. Okay, now B cap can be rewritten as mod B, B over mod B, right? So this will be OC cap, OC dot the vector B divided by mod of B. Okay. And now we're ready to rewrite everything. We know that the OC vector is just 1 over K plus 1. It's A, is it? Oh, OA, sorry about it. OA. Sorry, we wrote wrongly. Thank you. Okay, so this will be the mod of 1 over K plus 1 times A plus KB dot A, the whole thing dotted A, divide by 2. So obviously 2. So far, okay? Basically, I'm just replacing OC with 1 over K A plus KB. Yeah, sorry, it's supposed to be A. Yeah, made a mistake. Sorry about it. Okay, now you see disgusting things like this, right? There is a strategy to it. Pull out constants. Pull out any constants. So 2 is obviously a constant. Is there a constant at the top? Is there any constant in the numerator? There is, right? What's the constant? 1 over K plus 1. Okay, this is disgusting, so we pull it out because we know that we do not need to make it participate in the dot product. 1 over 2 K plus 1. Okay, now we do the mod of this. A plus KB dot A. Please remember the A's and the B's all must have the thingy underneath. The K, do not draw the thingy underneath. The K is a constant, so be careful. Now, how do you do this? Dot product, this is your distributive law reversed. 1 over 2 K plus 1 modded A dot A plus K B dot A. What is A dot A? Mod A squared, very good. Mod A squared. Mod A squared. Now, what is KB dot A? Do you know the value? Very good. Mod A, mod B, cosine 60. Very good. K. Mod B, mod A, cosine 60 degrees. If it's me, I'll write BA instead of AB. You know why? Because the formula is B dot A. Because usually, right, if you want to use A dot B, I would change it into A dot B first, then use AB. You get what I mean? Just to be very, very particular about it. But there's nothing wrong, just sharing. Okay. Nothing wrong, nothing wrong. Yeah. Okay, beautiful. And now we can rewrite everything. 2k plus 1 mod A squared. I believe we know that this is 2 squared plus k. Why is B1? Because B is a unit vector. Cosine 60 is half. And we are done. Shown. And that's answer. Which is 4 plus k over 2 k plus 1. Sorry? Yeah, can. Yeah, give me a shot. And there's no answer. What am Sorry. If you are practicing questions now in school, there's one question I recommend looking at that is pretty difficult. If you got time, we can look at it together. 2022 NYJC. The promo paper. J1 paper. J1 paper, promo paper, question 5. This is a vectors 2 question. This part, the scalar and dot product. This question is pretty tough. So recommendation, if you want, you can go and try. If you got time, maybe I can flash the question. We can try it also. Okay, but this is pretty good of a question. Okay, can I move on? Everyone okay? It's okay, just smile. It's just vectors. It's just vectors. Part C. Let's see. We need to find the area of the triangle OAC. So like I said, you need to be very careful of the way that we write our vectors. So triangle OAC, right? So OAC equals to half of A cross C. And this will be half of what? A cross 1 over K plus 1 A plus KB. Okay, question. Is there anything you can pull out? That should always be the first question that you should ask yourself. Anything you can pull out? Definitely, right? What can you pull out? K plus 1. I got people say before you can pull out A. I slap you. No, doesn't work that way. A is a vector. Vectors must stay within your mods. And then you plot constants. So this is 1 over 2 k plus 1. And this is just A cross A plus KB. And let's simplify this down. So we have 1 over 2 k plus 1, the mod of A cross A plus k A cross B. Now, what is A cross A? 0. Very good. This is 0. Okay. No, sorry, not divided by 0, but this is 0. Now, what is A cross B? What's the formula for A cross B? Yes, mod A mod B sin theta. Okay, so sorry, let me continue my working. So this is 1 over 2 k plus 1 modded 0, don't care. The k, we leave it as it is. Okay, we get this mod A mod B sine what angle? 60 degrees, right? And we're done. So this is k over 2 k plus 1. This is 2. This is 1. Now sine 60. Sine 60 is a special angle. Root 3 over 2. Okay, which is k root 3 over 2. K plus 1. This is the answer. Everyone okay? Anyone got any problems? Anyone going through midlife crisis now? No, Okay, very good. Okay, chill people. Chill. It's just vectors. You haven't seen the worst of H2 math yet. It's about to come. Which topic? Complex numbers? Learn already? Learn already. Nice? Do you like it? No. The next one that I would say is pretty bad is PNC. Permutation and combination. That one is the worst of everything. Okay, now, since I mentioned about that paper, right? Why not I show it to you? Let's try that particular question as well. Okay, so let me pull the paper. And then we try that particular question I want. Is it this? Yes, it's this. Okay, I'm going to flash a question on the screen. Please try. Okay, it's the same thing. It's a vectors 1 or whatever you call it. Vectors 2 question. If you want to demoralize yourself, this is one paper to try. Just saying. Okay, if you really want to boost, you want to bruise your ego, right? Try. Okay. Well, I think for my own students, you should also know this one is one to. Whoo, you'll feel like you're extremely down. Okay, so let's try. Start from here. Okay, I'll give you 3 parts. This is the easy parts of the question. We will show you one deaf part. Try, please. I love this question. Where do you get the papers from? Cannot see. Sorry. I'll walk around to see. Everyone start in the same spot. Or can write down everything in the question, but don't know how to continue. Correct. So you're given that the mod of 2b minus a is equal to 7. Correct? And then you get stuck there. Correct? So, can someone give me an idea of what you can actually do there? There is something you can do to help make that thing be a bit better. What can you do with the square? I mean, damn it! What can you do with the mod? Damn it! What can you do with the mod? Yeah, you can square it. Okay. Okay. So whenever you see mods like this, what can you do? You need to square. Okay. By squaring it, you can actually get rid of the mod. So let's do it together. So you have the mod of 2b minus 7. Okay, 2b minus a equals to 7. So 2b minus a squared equals to 49. Now, when you square a vector like this, what does it become? like what is it? Is 2b minus a, 2b minus a. What's the thing in the middle? It's a dot. Okay, equals to 49. Now let's expand. 2b dot 2b is what? Yes, 4 mod b squared minus 2b dot a is what? No. Don't need. B dot a. Can already. Minus a dot 2b plus minus a dot minus a is what? Mod a squared equals to 49. Now, can you clean this up? You can. For the value of b is given as what? 3. The value of b is 3. Now, minus 2b dot a minus 2b dot a minus a dot 2b. Are they the same thing? No. They are. It's just minus 4 a dot b plus mod a squared, which is 5 squared. Sorry, I forgot to square here. And this is 49. Simplify, get your answer. Beautiful question. A dot b equals to 3. Sure. Will we have a copy of the paper? I put inside the Dropbox later. Okay, so this is the answer. So far, okay? This is arguably the second easiest part of the question. So just remember, whenever you see mods, okay, you can just get rid by using a square. Okay. Behind all okay? Everyone okay? Okay, nice. Okay, moving on to the second part. Can we move on? Hey, relax. Don't need to scared. Why everyone so scared? Relax. This is damn fun. Part 2, try. Answer, please. Deduce the length of projection of OA onto OB. Yes. Again? One. The answer is 1. Okay, so the answer is 1. Okay, so if you don't know how to get it, okay, please watch the working in a short while. It's always A cross A or B cross B that is always equals to 0, is it? Yeah, correct. A cross A is 0. Okay, so how do you do this question? Just very quickly, A dot B over B equals to 3 over 3, which is 1. Finish. What? It's good. In life, give you simple question, then you should be happy. Now we try. Okay. Okay, please try. Yeah, you want to ask something? or it's related, the question, just saying. So I give you the information from the previous parts just to help you. 2b minus a equals to 7. The mod of a is 3, I think. No, is it 5? 5. The mod of b is 3. I think that's about it. That's the only information you get. Oh, and a dot b is 3, I think. Okay, please try. Then minimally you should get the positional vector for P first. That's the one. The rest is the one. KA plus B. One is one is one. One is Q. One is Q. Oh, yeah, yeah. This is just oh, okay. What's wrong? You know why? Because of the ratio. To me, the ratio. No, this is not. Yeah. This is AP over P equal to K over 1. Yeah, that's right about that. Yeah, but this is become better. You can go through in a short while. Maybe not too many. Okay, anyone can show? Yeah. Oh. Okay. How you know the economy is busy? So how you know the 14 was for them to contribute to quite close. Yeah, but it's the same one. Not correct, not the best way of doing it. Yeah, same problem. So the 78.461, how you know that this is equal? Oh, yeah, that's right. Nice. Very good. Okay, so can do. Cannot. Behind can. Only one person can. Okay, if you can, very good. Later, I share the answers with you later. Okay, let's go through first. So the ratio theorem, everyone knows, right? The OP equals to KA plus B over 1 plus K. Okay, it's a straightforward. Now let's find the area. So area is equals to half OP cross OA, which is just half of KA plus B, 1 plus K cross A. Correct? And now, same thing, we pull out things that are disgusting. Pull out constants, I mean. So constants are this. So this is 2, 1 plus K. You get KA plus B cross A. Correct? So far, okay, right? And then after that, 1 over 2, 1 plus K, KA cross A plus B cross A. Now, we know that A cross A is 0. So it means whatever is left behind is just 1 over 2, 1 plus K. Now, B cross A, just now we already mentioned, with the mod, is the same thing as A cross B. Simple. Okay, and this is the problem that most people face. Reach here and get stuck. How the hell do you get your A cross B? Correct. Okay, so this is when magic must happen. So we know from the previous part that A dot B equals to 3. Correct? Now A dot B can be rewritten into another form of mod A, mod B, cosine theta is 3. Which means that this is 5, this is 3, cosine theta equals to 3, cosine theta equals to 1/5. Correct? This is where it becomes a bit different. If you solve for theta and then you give a decimal, it's a bit strange. You shouldn't have done that. Instead, what can you do here? What do I want? Okay, we write our objective first. We know that A cross B is what? Mod A, mod B, sine theta. I have a cosine theta. How to find the sine theta? Draw triangle. Draw triangle or your identities. Okay, so we draw triangle. Okay, so we draw a triangle. This is theta. Cosine is 1/5. What is the opposite side? Is 2 square root of 6. So this means that sine theta is just 2 root 6 over 5. And we're done. equals to 1 over 2, 1 plus k, mod A, mod B, 2 square root of 6 over 5. Final answer, 3 square root of 6 over 1 plus k. Shown. Of course, we change the A to 5 and B to be 3, obviously. And voila. Why is this difficult? It's because of pulling this from your backside. Not the easiest thing in the world, but possible. Not the easiest in the world, but good job, nonetheless. Okay. Any questions before we move on? Let's do one disgusting kind of big trigo question. Trigo. Sorry. I mean factors. Sorry. Factors question. Okay. Let's try from the notes again. All okay? Everyone here? Behind copy finish. Nice. Okay. Now you choose. You want punching bag? You want shooting a bullet? You want a disco ball? Or you want a laser shooting a drone? Which one you want? You want from Hwa Chong, NJC, or EJ? Whichever you want. We choose any of these, this one more fun. More visual. Hwa Chong, okay. Hwa Chong, he say one, not me, Okay, Hwa Chong, please. 15 minutes. Try. Welcome to hell. Yeah, this one, the drone shooting question. We might extend by a little bit, okay? I want to go through the whole question. Just a little tiny bit. Anyone need to rush off or anything? If you need to rush off, then you can go ahead. If you want more like this kind of questions, I have a lot. I got one Spider-Man swing from one corner to another corner. I have one is like you play Amazing Race around a field. That one quite fun also. Another one is like someone shoot a guy. They need to check whether the bullet flies straight off got curve. Quite a cool question also. If you're interested, you can flex me. I can show you the question. The easiest part. Just get the idea. Okay, we don't have a lot of time. Okay, so due to time constraint, I'll just show you the answers. Okay, but then I'll drop the answers also into the job box also, because the question will take very long to solve. Okay, yeah. Because I did have another session one more time at Serangoon later. Okay, I see. So I'll show you the whole entire answer. Give me 1 second. Where is my Zoom? Oh yeah, my Zoom is there. Okay, can you see my screen? Right. Okay, I believe you should be able to see my screen. Okay, so how do you do this question? I don't have the question, I never flash the question, so you see yourself. Okay, but here. So first thing you need to do is you need to search out for the equation of the line MD. Okay, and then you find the direction vector of your ND line and find the equation. Now, once we have found the equation of the line ND, okay, you can intersect it with the line ND to find D lah. Okay, you get your 3 equations here. And then you solve for your lambda and your mu, which will be -3/25 and mu equals to 2/5. Sub in, solve. Get answer. That's how I'll do the first part. Okay, so bare minimally, you must be able to reach until here. Get the equations out. Okay. Any questions so far? Yeah, I'll send out the answers, so don't need to worry. Yeah, don't need to copy. Just understand carrying. Okay. Okay, move on. Now the question also states that let me read the question. So okay, they say the drone catcher is using a net to capture the errant drones. It's deployed instantly from the origin point. You need to find the acute angle between the flight path of the drone catcher and the horizontal ground. So for this, you need to understand what does it mean by the horizontal ground. Okay, so for the horizontal ground, now what do we know? This horizontal ground is what plane? It's the XY plane, correct? Because it's on the ground. So what can we can write an equation of the horizontal ground, which is r dot 001 equals to 0. Okay, this is the equation of the horizontal graph. Now, why is it equal to 0? Because the origin contains the plane contains the origin. That's why it's equal to 0. Okay, and then you sub in, solve for your angle. Then the answer will be 11.1 degrees. You can sub in the value, go and try, you can get the answer. Okay. Now, the next one, so far, okay? Moving on. At the same time, there's this jammer gun that's emitting a signal to jam the control signals from this errant drone. Okay, who cares? The jammer gun is located at the point G, and the plane containing plane P contains the points T, M, and N. Show that the equation of the point P is equal to the following. So we basically just need to search out for all the different coordinates. So we know that the F traffic control room is 70 meters above the ground. So we can work out that T is 0.07. We can find the direction vector of the line NM, we get this. We can find the direction vector of the line TM, which is this. And then to find the equation of a plane, we just take the cross product. You cross these two together, you will get this equation of the plane. You get your answer.
Why is now the R got 1 at the bottom again?
Why? Because that is the equation of a XY plane. This is the formal equation of an XY plane. Yeah. And then you get this, you get the equation. So far, okay? It is also known that the jammer gun is at the foot of perpendicular from the errant drone of the plane P. Find the coordinates of the jammer gun. Okay, this one is a bit chim, so just slowly. The equation of the line perpendicular to P passing through D is the following. Okay, and then we can sub the line into the plane to get the value of T, which is that disgusting thing down there. And then you sub it in, get your coordinates. Okay. And the last thing, for part E, you're looking for the distance between the jammer gun to the drone. Okay, and you get your answer. Okay, this is one of the more interesting kind of questions that are out there. Okay. Yeah, so you can slowly go and read and go and try the questions. Okay, if you want to see, there are many types of these kind of questions out there. Okay, so I'll just remove. Okay, everyone okay? Yeah, you need to try it yourself, no choice, in order to get better at this. If you want, I can show you. Okay, for those physically here, I show you something interesting. Okay, I mean, the most ridiculous questions that I've seen so far for vectors is this kind. Wait, just for the physical people. Wait, sorry, give me 1 second. Let me pull the question for you. And then we can end off. Yay. Okay. So, okay, you see the screen, So I think some kind of interesting questions that you can see. For those that are online, if you want to see, you can see as well. I think the most interesting one I've seen so far is like this. Yeah, okay. Vectors. Yeah, so it's basically you have a warehouse, you have a guy standing here, he shoot 2 bullets, then you get 1 bullet at here, 1 bullet at here. Then he shoot a guy, the guy died here. Then you need to check what happened. Pretty cool question. And okay, the rest are not important. There's one more I just want to show. This one, I think if you move into J2, you will definitely see before. You will definitely see. Okay. Okay. So if you're planning to go to J, I mean not planning to go to J2. I mean if you go to J2, sorry, you will see something like this. Okay, this is interesting. So you might want to prepare yourself. This came from your school. Okay. So credits to your school, Porsche, Stolia. So you got the median, you calculate this. And then looks fun. Yeah. Okay. And then the question is like that. Okay. Yeah. There are many types out there, many very creative teachers out there in school. Okay. So yeah, I do hope that if you want more questions like this, you can always text me. I can give. If you really want to see like the interesting stuff, you can always text. I will give you. Okay, so without further ado, that's all. Okay. Yeah. I hope you learned something. Hope you enjoyed it. Okay, that's basically it. Thank you for coming. Okay, for those online, thank you very much as well. Bye-bye.
I don't use it for the exact